We are trying question on Kirchhoff's laws. Let's try number 15. In deriving a formula for combined resistance of three different resistors in series, Kirchhoff's law are used. Which physics principle is involved in this derivation? Okay, I just draw for you a picture. Yep, what's your answer?
Either A or D.
Conservation of charge is parallel. Right? Conservation of charge is through conservation of charge is conserved. Current through each resistor in series is the same. And direction of flow of current is from positive to negative, so it's false. Only electron current, nothing to do with Kirchhoff's law. Potential different across each resistor, false for the resistors in parallel. PD across each resistor is the same. Nothing to do with Kirchhoff's law. For resistor in series, the current is through each resistor is constant. Nothing to do with Kirchhoff's law. Okay, the
Yeah.
answer is A. Conservation of charge.
Yep.
But right, it's a tricky question. Right? We are using the current through each resistor is the same. Conservation of charge. But right, it should be conservation of energy. But anyway, you have to be careful. Okay,
What's charge again?
say again.
What's charge?
Charge. Positive, negative charge. Or in this case, current, electron. Flow of current is the flow of electron.
Oh, okay.
Okay. The safety on railways is increased by using several electric switches. In diagram, switch PQRST, PQRST control the current to the green lamp. The green lamp. Which row does not allow the green lamp to light up? Yep. That's your answer.
Um,
Yep.
maybe it's C.
Okay, let's see. You close R, open Q, now no current will flow through here. Current will flow through R. And close S, close D, the current will flow through. No. Open P, open Q, no current can flow through. Close R, open S, close D. As long as R is closed and T is closed or S is closed, there's going to be current that's going to be lamp to be light up. So which is the answer?
Oh, the answer is D.
When P or Q and R are open, no current can flow through the green lamp. Answer is C. Okay,
Oh yeah, I said
correct.
C, yeah.
You can see P is closed, open, no current will flow through here. And R is open. As long as R is open, no current will flow through again. Whether these two is closed doesn't matter. Okay,
Oh, so R is the most important one.
as long as P and R are open, no current will flow through. Or P or Q and R open, no current will flow through. Okay.
Ah.
Okay, next question. Number 20. Four identical resistors are connected in three networks below. Which arrangement has the highest total resistance and which has the lowest?
Resistance. I think the second one is the highest resistance. Lowest is the third one.
Have to work it out. Lor. Answer is C. Work it out.
Wait,
Right? For the first one, combine these two is 2R. So these are parallel. Right? Ri is 2R over 5. Replace this one with 1. So it's half R. Half R is 3 over 2R. So work it out. Lor. And this is 3R. Let each of them be R. So this is 3R and R. Okay. The smallest one, the largest one. Can
yeah.
step by step. Lor. Can try the
Okay,
rest. Yeah.
I thought you said parallel will have higher resistance.
No, 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 no. No. You have to work it out.
Oh, it's not fixed on now. It could be parallel, could be series, right?
This is a combination now. Series and parallel. Series and parallel. So you have to work it out. Lor.
Right, that's true. Good.
How about this one? When four identical lamps P, Q, R, and S, P, Q, R, and S, P, Q, R, and S are connected as shown in diagram 1, they have normal. When the four lamps are connected in as shown in figure 2, which statement is correct? The lamps do not light. The lamps are less bright than normal. The lamps have normal brightness. The lamps are brighter than normal. What's your answer? Yep, they are the same. Normal brightness
This. Oh no,
is the
yeah.
same, right? These two in series. These two in series. These two in series, these two in series. Right? This one is taken out as all. You can take it out if you want to. It's the same thing. Answer is C. Lamp has normal brightness. Circuit are the same. Right? Can redraw that. Right? Can redraw that. It's almost the same thing as that. How many loops are there? Number 30. How many closed loops are there? Okay.
This one looks like there's two closed loops.
One. Right? That's one of them. Two. Right? The whole thing.
And then three.
Three. So in any,
Oh, okay.
you need only three equation. You got three. You got any three equation. One of them is Kirchhoff's first law. The other two is any two of the loops there. Can to solve the equation. Let's try some more question on that. Okay. Calculate this one. Calculate I1, I2, I3. Yep. Apply Kirchhoff's current law to junction C. Right? I1 is going into the junction. I3 is going to junction equals to I2. It's happening to my slide. What is happening to my slide? Okay, consider the loop A, C, D, E, B. A, C, D, E, B. Right? This loop there, using Kirchhoff's voltage law. Right? We are taking it anti-clockwise, where the current will flow. So 6 volt. EMF is 6 volt. PD, I2 passing to here. I1 passing through this one and this one. That's why we have this one. 4 times I2. So I find the equation. Can or not? Yep. Anything, any problem? Anything not clear? You can ask.
Hmm.
We just take this loop, that's all. When you calculate I1, I2, I3, usually it's not that complicated lah. They just want you to write the equation only lah.
Yeah.
Okay,
Okay.
consider loop G, F, C, D. That means clockwise. Right? That's your EMF. Right? I3 plus to 1 ohm. I3 times 1 ohm. I2 plus to 4 ohm. 4 times 2. 4 times I2. Okay or not? Stop me if I'm going too fast.
No, it's okay.
As long as you can get these three equation, then it's a bit of math as well to solve it. Right? Can get rid of
Yeah.
right? You want to solve this one, I1, I2, to get rid of I3, no? Replace I3 with this equation, no? Right? I don't think I will go to that, as long as you can get the equation. Let me see. Number 33. This is a partial question. Two cells, E1, E1, E2 are connected in series with a resistance R1, R2, R3, as shown in the figure. Current I1, I2, I3 in the various parts of the circuit are shown. They are very kind to you all. I give you the current direction. My time we have to draw our own current direction. So write down the expression for I1, I2, I3. Yep. How are they related? Look at the junction. No? Junction B. I1 going in, I2 going in. Add these two together equals I3. No?
Oh,
Yep. That's all.
yep.
Then use Kirchhoff's second law and write the relation between E1, R1, R2, I1, I3 to loop A, B, E, F, A. Right? This loop. Write for me the equation. Usually they won't ask you to solve because it takes too long time. It's a math problem already. I'm more interested asking you to write the equation. Yep. What's the equation? Sum of EMF equals to sum of PD. No?
The voltage law.
Yeah, voltage law. This loop there, E1 and I1 times R1, I3 times R2. That's all. Try the next one. This loop. A, B, C, D, E, F, A. This loop. You can choose clockwise or anti-clockwise, up to you. What's the equation? Yep, 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 yep.
I1, R1, then
I1, R1, and
I2,
I2,
I3, R2.
right? This one send out current, so it's E1. This one send current opposite direction, so it's minus E2. And this one is I1 times R1. Right? We are choosing anti-clockwise direction. I1, R1, correct direction. This one in the opposite direction. So we subtract. Can or not?
Oh yeah.
You are still not familiar. Okay, how about this loop? Use Kirchhoff's second law to write the relationship between E2, R2, R3, I2, and I3 for loop D, D, C, B, B, E. Yep, what's the equation? Can or not? You look a bit lost after I go through with you.
This thing is not in my it's not in my notes. Not in my iPad.
Ah, not in your note, right?
I only have until the previous one.
This is not in the past year
Yeah,
question.
I only have until Roman 2 2.
Huh? What do you mean Roman 2 2? We are just using Kirchhoff's second law, that's all. Yeah, this is the direction, sending out current E2, and in the same direction, I2 times R3, and around this one is I3, R2, that's all. Sum of EMF, sum of PD, which is not clear.
This is for the E1, E2, R1, R3, L1, right?
For
For
this loop,
loop A, B, C, D, E.
for this red loop, this red loop, I'm taking it anti-clockwise. Sorry, clockwise. So if the current flow in the direction of your choice, then it's positive. This is also positive. Current flowing in the direction of your choice. Whereas just now it's flowing opposite the direction. That's why we got negative. Yep. Do not ask what's the problem. You are still very stuck. You are still a bit lost.
Sure, but this loop is just B, E, D, C, isn't
D,
it?
E, I drop like D, C, B, E. That's the direction I'm choosing. Clockwise.
B, E, D, C.
Mm.
D, C.
D, C, B, E lah. D, C, B, E. Show you the rate.
Oh, but this is not in the question, right? This is
It's
extra.
not the question I add in just to
Okay,
let my
okay.
students see whether they can solve the problem or not. Can write in the equation. Looks like yeah, still a bit lost. Okay, let's try this one. IV graph of component A and B, current through the and PD across component A. Component B is given the graph. Component B, component A. And we are looking at component B. Is this an ohmic or non-ohmic conductor? Yep. You should be able to tell me straight
I
away.
think it's not.
Not
It's
ohmic
not.
conductor, right?
Doesn't follow Ohm's law.
And what is the resistance across a component when the current passing through is 5 milliampere? Right? We have 5 milliampere. And estimate the potential difference V over I, right? At A is here. 5 milliampere is about, right? It's about 0.7. Very hard to estimate, but it doesn't matter as long as you know estimate. But 0.7 divided by 5 milliampere, change to ampere, 140 ohm. Component B, right? Component V, 5 milliampere. This one is about 2.2, 2.3 there, divided by 5 milliampere. Okay, not? Yep. Talk to me. Anything not clear, better ask. Yeah, still not ready yet.
I mean, yeah, this one cannot because it's VOI.
We are just applying the formula V over I,
Yeah,
that's
this one
all.
can. This one can. This one can.
Then just read from the diagram what is the value, that's all. Straightforward.
Yeah.
If component A and B are connected in series in a circuit and the current in B is 5 milliampere, what would be the current in component A? Yeah, 5 milliampere pass through B. What's the current through A?
Five milliampere pass through B.
Ah, current through A. Same, no?
Yeah,
5
it should be the
milliampere.
same.
It's in series, series.
Oh, okay.
Potential different across A. Read from the graph, no? Yeah, read from the graph.
Yep.
5 milliampere passing through A and B. So potential difference across A is there, right, about 0.7 volt. Potential difference across B is what? Yep.
Across B.
Estimate 2.3 from graph. What is the problem? Anything that is not clear?
Yeah, I mean, you just compare with the graph, right?
Just reading the
Like,
graph and then
yeah,
just
yeah.
5 milliampere there, read potential difference. 5 milliampere read potential difference. You still got 10 minutes left.
Yep.
What's the potential difference across A and B? Or the EMF of the battery?
Plus,
Add the two together, 3 volt.
yeah, plus.
Okay, A and B are connected in parallel, as shown in the diagram. A cell of negligible internal resistance. The current through A is 50 milliampere. What will be the potential difference across A? Yep. Are you tired or what? This is reading from graph, that's all. Nothing much. Nothing much. Reading
Ah, 15, 15, so it's
50 milliampere.
2 volts.
2 volt. Potential difference across B,
4.
almost 4 there lah. No, I cannot read like that. Potential difference across A and potential across B is the same. It's parallel. This is 2 volt. Okay now.
Potential difference across A is equals to progressive.
Yeah, they are
Yeah.
parallel.
Because it's a series.
So 50
Alright.
milliampere is is passing through A, not passing through B. So you can read from here is 2 volt, but it's not passing through B. So you have to use, this is just playing with you whether your knowledge is good. Right? PD
No, no,
across
no.
each resistor is the same. Right? 2 volt. Current through the component B. Read from the graph also. Current to component B. Yep.
True.
Estimate from here. 2 volt across A and B. So it's 2 volt. So it's 4 milliampere from graph. Right? What is the current supply of the battery?
The EMF, no.
No EMF. Now this applying Kirchhoff's law, that's all.
Oh, okay.
You know the current through A, you know the current through B. So
And
Kirchhoff's
plus
current law, add the two together. Lor.
oh,
Yeah.
A plus B.
Ah, current through A plus current through B. Lor. Okay, now.
Yeah.
So this one just summarize for you what you need to know. Lor. Okay, anything else you want to ask? You got 6 more, that's about 5 minutes left. Anything
I
else?
don't have.
You try to do some question in motion in 2 dimension. Lah. Okay, let's go to review. I don't think we have much time to cover. Non-linear motion. Make sure you know how to resolve the component. Next to the angle is VU cos theta to sin theta. Theta is angle of projection. U is the initial velocity. And maximum height. These are equations. Don't memorize know how to derive that. And throwing a ball horizontally. Right? Horizontal motion, uniform velocity. Vertical motion, uniform acceleration. That one you need to remember. Uniform velocity horizontally. Uniform acceleration vertically downwards. At any time, we combine the two components to independently as vectors to find the velocity. Right? Let's find the resultant velocity. Example at this point, you add a horizontal component and vertical component at that point, and find the resultant. Okay, try this one. What's the answer? A football is released along a plane, sloping surface and bounces several times. The diagram shows its path between its bounces x at x and y. Assuming there is no air resistance, which of the following graph correctly shows the variation with time t of the horizontal component of its velocity vh between x and y? Yep,
Uh, horizontal component. So it's like, is it moving?
it's bouncing. This one is just
No,
starting
it's
whether you
about,
understand what is happening.
yeah, but it's B, it's
These
B.
are partial question. Partial question, question
I
on
think
page
it's B.
85. Horizontal component constant.
Yeah, it's B.
B. If it's vertical component, then answer is donkey. Lor.
Yep.
Okay, what's the answer for this one?
This one
Good.
must memorize one.
Try not to cancel next Tuesday class, and then tell me what you want to do. So what's the answer for this one? 203 June, paper 1, number 7.
This one must memorize formula one.
Say again.
Must memorize formula one, is it?
This one is just starting your understanding, that's all. What will be the
Oh,
vertical and horizontal component at time t? A bit of derivation.
vertical is sine now. But I'm not sure about minus GT though. Oh, wait. Yeah, minus GT because got gravitational pull. Ah, I
Horizontal is
see.
constant, u cos alpha. Vertical motion, right? Initial vertical velocity is u sine alpha. A equals to minus g. We take ours as positive, t and v. So taking ours as positive, v equals u plus at. Put in your equation. Answer is 0.
Yep, got it.
Okay, anything